Air distribution systems. The references for this particular procedure is going to be reference appendices RA 3.1, found in the same locations as explained before. The performance compliance calculations allow credit for duct systems that are designed to be in advantageous locations, that have reduced supplied duct surface areas, and or that provide higher R values for portions of the system. The overall training goal for this particular section is to gain proficiency in the HRS testing and verification protocols related to the air conditioning distribution system, so basically the duct design. And this is everything we're going to be covering in this particular PowerPoint. So we're going to be talking about the procedures for verified duct design, ducts in conditioned space, 12 linear feet or less of duct located outside of conditioned space, return duct design, air filter device design, and the verification of prescriptive bypass duct requirements, and obviously the applicable forms that go with those inspections. So verified duct design, all the items that we're going to be talking about, except for the bypass ducts in this particular PowerPoint, are performance measures. So for compliance criteria, the duct system design shall be based on an industry standard design methodology such as ACA Manual D or equivalent. The requirements are that it shall be verified, visually verified by a HRS rater. The duct design layout shall meet all applicable duct design and documentation requirements, and the duct design layout shall be approved by the enforcement agency, meaning that it was submitted and approved by the actual building department. The layout itself shall include a scaled layout drawing, the location of the space conditioning equipment, the location of all supply and return register grills, the diameter, length, R value, allowed bends, and location of each duct segment, and all other supplied duct detail reported on the Registry Certificate of Compliance. Now for approval, the layout shall be included with the building design plans and the Registry Certificate of Compliance submitted to the enforcement agency in conjunction with the application of the building permit. When we say Certificate of Compliance, we're talking about the CF1R. It shall be made available to the enforcement agency, installing contractor, and HRS rater for use during the installation work and for all applicable inspection. So the HRS rater, you will have to visually verify that what's being installed in the house exactly matches what's on that approved set of plans. So during the field verification, again, the HRS rater shall verify the location of all supply and return registers by the inspection of the interior of the dwelling unit. This is obviously done before the drywall goes up because you're going to have to inspect the actual ducts and where they're running to and from. The location of the space conditioning equipment. The diameter, length, R value, allowed bends, and location of each duct segment by observation of the spaces where they're located. And also you're going to make sure that there is no deviations from the original design. So deviations are not allowed without a revised duct design layout approved by the enforcement agency. So if the contractor or the builder decide to change something midway without getting it pre-approved from the building department and go through the submittal process again, that would be a failure from the HRS rater standpoint. Now, there are also credits that have to have verified duct design as a prerequisite. So supplied duct surface area reduction, buried ducts, or deeply buried ducts. So if any of those three credits show up on the CF1R, the verified duct design is also an additional requirement. It will be listed on there, but this is just as a heads up. The verified duct design is a prerequisite of these three additional tests. Now for supplied duct surface area reduction, the field verification is a verified duct design that it's a prerequisite for compliance with this particular credit, like I just mentioned. A visual inspection shall confirm the installed duct system layout conforms to the duct design layout as previously described. For buried ducts, The field verification obviously still involves a verified duct design and QII. Those are both prerequisites for this particular credit for compliance with the buried ducts compliance credit. This procedure shall be carried out prior to covering the ducts with insulation. So if you have buried ducts as a compliance credit, a verified duct design and QII will also have to be performed in order to be compliant.
So the field verification of the buried ducts credit will require you to do the following items. First, any ducts that are designed to be buried shall be insulated to R4.2 or greater. Oftentimes the prescriptive or compliance side of things will require a value greater than 4.2, but that is the absolute minimum. Any ducts that were designed to be in contact with the ceiling shall be not more than 3.5 inches from the ceiling drywall. Generally, the bottom chord of the trusses are 2x4s. 2x4s are not 2 inches by 4 inches, but they'll be 3.5 inches tall. So if you have a 2x6 bottom chord of a truss, the ducts will not be allowed to run up and over that, because then that will exceed that 3.5 inches. So make sure that they only go that far off the ceiling. You'll need to have a sign that's hung near the attic access that displays a warning, caution, buried ducts. Markers indicate location of buried ducts so that other contractors and trades don't go around and step on those ducts on accident and crush them. And then finally, to further identify them, all ducts that will be completely buried shall have vertical markers that are visible after insulation installation, and they will be placed at least every 8 feet of duct length and at the beginning and end of each duct run. This way it makes it easily identifiable to those that need to go moving through the attic after those ducts are buried to identify the location of those ducts.
For deeply buried ducts, very similar to buried ducts, the verified duct design and QII are still prerequisites for this credit, and obviously this still needs to be verified before the ducts are covered with insulation.
So the field verification for deeply buried ducts is virtually identical to just buried ducts. We have the same 4 items. The ducts need to be insulated to R4.2 or greater. They need to be no more than 3.5 inches from the ceiling drywall. We need to have that sign near the attic access, caution buried ducts, markers indicate location of buried ducts, and all those ducts need to be identified with vertical markers every 8 feet of duct length and at the beginning and end of each run. So the only difference between buried ducts and deeply buried ducts is how thick the insulation is above the duct itself.
So now we'll be talking about ducts in conditioned space. So for ducts in conditioned space, for field verification, the HRS rater has to verify the space conditioning systems are located entirely in the conditioned space. This is including the furnace and the coil. If any part of the space conditioning duct system is outside of conditioned space, the system does not pass. Now the following 2 credits have ducts in conditioned space as a prerequisite. Low leakage ducts located in conditioned space and a low leakage air handling unit. So if any of those 2 apply, the ducts in conditioned space credit also has to be verified. So for low leakage ducts in conditioned space, obviously the ducts in conditioned space is a prerequisite for this credit. And then duct leakage to outside has to be completed on the system as well. So we talked about duct leakage systems and testing earlier. We talked about total duct leakage and duct leakage to outside. So for this particular credit, there has to be a duct leakage to outside that takes place. If the leakage is less than 25 CFMs, then the system passes. For the low leakage air handling unit, for field verification, obviously the low leakage ducts are a requirement, and then the air handler shall be included in the list of low leakage air handling units published by the Energy Commission. Now, to verify 12 linear feet of less of duct located outside of condition space, you want to verify the space condition systems with air handlers located outside the condition space have 12 linear feet or less of duct located outside of the condition space. This is including the air handler and the plenum. You're just measuring the ducts and making sure that it's less than 12 linear feet. If the space conditioning system has more than 12 feet of duct outside of condition space, then the system does not pass. Now we'll talk about the verification of return duct design. So in lieu of the fan water draw and coolant cool airflow for non-zone systems and non-zone systems only, the verification of return duct design for return ducts and grill sizes is allowed. We had talked about this originally in the Title 24 overview section when we talked about the HVAC requirements. So verification shall consist of a visual inspection to confirm that the duct design conforms to the criteria given in Table 4-10 for single return systems and Table 4-11 for multiple return systems. And this is Table 4-10. So basically you're going to visually verify that depending on the tonnage of the unit, if this is a single return duct system, that the return ducts meet those particular sizes and the return filter grill gross areas meet those particular sizes as well. For multiple return systems, this is the other table, except that now with multiple returns you can go up to 5 tons, and now you obviously have 2 returns and 1 overall return filter grill gross area. And these are just visual verifications. You're just measuring the sizes and comparing them to the tonnage of the system to make sure it complies.
In addition to verifying the size of the return grill and the various ducts, return ducts, if there's a single return or multiple returns, there's 3 additional items that we need to verify. The first is that the return duct length for each return air filter grill shall not exceed 30 linear feet. So if you do have 2 returns, each of those can be no more than 30 feet long. The return ducts shall not contain more than a total of 180 degrees of bend. So as they make their way from the filter grill over to the return plenum, they are going to have to make some bends. They cannot have more than 180 degrees of bend. So that's the same as 2 90-degree turns. That would be all that they would be allowed to have. And finally, if the return duct contains more than 90 degrees of bend, one of those bends shall be a metal elbow. So while you are allowed to have 180 degrees, you're only allowed to have 90 degrees of that bend be flex duct. Anything beyond that, metal elbows will need to be installed. So those are the additional requirements for that alternate method.
The verification of return duct design is also part of HERS inspections. So for air filtration, except for evaporative coolers, any mechanical forced air heating and or cooling system with more than 10 feet of duct must meet 4 sets of criteria: the system design criteria, the air filter media efficiency criteria, the air filter media pressure drop criteria, and the air filter media labeling criteria. So the design criteria basically means that all recirculated and outdoor air passing through the heating or cooling device must first pass through the filter. The design airflow and the design pressure drop through the filter must be determined by the designer. The design pressure drop will determine the size and depth of the filter media required for the device. So basically, you're just making sure that whatever is being installed matches what's on the plans and what was specified by the designer. As we mentioned earlier, if the system design elects compliance utilizing the return duct design alternative specified in the tables that we talked about before, then the designer must assume a designer filter pressure drop of 0.05 inches of water column at the applicable design airflow rate. So if they're using those 2 particular tables, the value for the design filter pressure drop automatically defaults to 0.05 inches of water column. Replacing the filters when they become dirty brings their resistance to airflow back to the design condition. Therefore, the filters must be located to allow access for regular service by the occupants. Part of the design criteria includes a clearly legible label, such as shown right here on the right hand side, and it shall be permanently placed in a location visible to a person changing the filter. The filter media pressure drop specifications at the design airflow rates that fall between the 400 CFM's increments must be determined by interpolation of the standard 680 rating values, or by lookup method made available by the filter media vendor or manufacturer. For air filter media efficiency criteria, the filter media shall be MERV 6 or better to provide protection to the equipment and potentially provide health benefits. Filter media that provide at least 50% particle efficiency in the 3.0 to 10 range in the HRI 680 are considered to meet the MERV 6 criterion. To ensure airflow for efficiency heating and cooling equipment operation, the installed filter media must conform to the design pressure drop specification shown in the filter location label previously described. And this is to verify that the air filter media pressure drop actually meets the design standards. The filter media product has been labeled by the manufacturer to disclose performance ratings that meet both the efficiency and pressure drop criteria previously described, as shown in the filter location label. So this will verify that the proper filters are being installed. The verification of prescriptive bypass duct requirements for zonally controlled forced air systems are also a requirement of HERS raters. So what is a bypass duct? A bypass duct is a short duct placed between the supply plenum and the return air plenum. The purpose of the bypass duct is to allow the excess pressure from the supply plenum to escape into the return air plenum. Excess pressure can occur in the supply plenum when less than all the zone dampers are open. Excess pressure is escaping through the bypass dumper is taken back into the return air system and recirculated through the equipment. And this is a diagram to show how the bypass duct is usually designed and installed. In order to field verify the bypass ducts, a visual inspection shall confirm that bypass ducts that deliver condition supply air directly to the space conditioning system, return duct airflow, are not used, or if the certificate of compliance, the CF1R, indicates an allowance for use of a bypass duct, the bypass duct shall conform to the specifications given on the CF1R. So you as a HERS rater, you're just going to visually verify whether there is a bypass duct present or not, depending whether the CF1R is calling for it or not. If the zonally control system meets one of the two previously described criteria, this system complies. And now we're going to list the forms that are used for these inspections. The CF3R MEC 20 Bravo is used for low leakage ducts and condition space. The CF3R MEC 20 Charlie is used specifically for low leakage air handling units. The CF3R MEC 21 is used for duct locations. The CF3R MEC 28 is used for return duct design and air filter device sizing. The CF3R MEC 29 is used for duct surface area reduction, R value, and buried ducts compliance credits. And if you have any questions, again, feel free to call us or shoot us a message through the messaging system or email.